Sorry, crap. Good afternoon, Digital Bangkok. I've understood I'm the last speaker of today, so I'll try to make it an energizing finish. And what I'll talk today about is about data monetization, and it involves the most fascinating of all disruptive technologies, which is artificial intelligence. My name is Michael Gryseels. I lead the digital delivery unit of Mckinsey & Company. We help companies build digital businesses, products, and experiences, and by doing that, help them to reinvent themselves in the digital age. And that involves us getting involved in the most advanced technologies. One of them is artificial intelligence, and I'll be glad to talk more about that today. I've got 4 topics to cover. One is, we hear a lot about artificial intelligence. In fact, it's been around since 1950. Is this a hype or is it real? 2 is, where is the money? If you're a business, where is the money in big data and artificial intelligence? 3 is, how do we unlock that value for companies, for industries, and for society? And lastly, I'll leave you some thoughts on what I think Thailand should do to benefit maximally from this. Let's start with, is this hype or is this real? The gentleman on this picture is Elon Musk. He's probably the most courageous and daunting entrepreneur in the area of advanced industries and technologies. He's built Tesla, he's built SpaceX. He will say that the most scary technology out there today is artificial intelligence, because it has the potential to overshadow the human race. Now, why is that? This technology has been around since 1950s. Is it hype? Is it real? It is real for 3 reasons. Number 1 is the cost of data storage and processing. One way I'd like to express that is the amount of computing power that you can buy with $1,000, 35,000 baht. Now, until in the late 90s, most computers really didn't have much power. It has only changed in the last 10 years. In fact, in the late 90s, any insect had more brain power than the average computer. In 2005, a computer you would buy for $1,000 would have more brain power, more computing power than the brain power of an insect. Today, the computer that you buy has more computing power than the brain power of a mouse. In 10 years from now, the computer you will buy for $1,000 will have more computing power than your brain. That is how fast this is going. Number 2 is just the increasing amount of data that is available. 90% of all data that has been generated on this planet has been generated in the last year. People are active on social media. You're taking pictures, those are going on the web. Every day, every year, more pictures are being created than in the last, ever. And this is not only humans. I would say the biggest source of data in the future is going to be machines with the Internet of Things. By 2020, we expect that there will be 200 billion machines connected to the Internet. All of them will be generating data. The last vector why this is becoming real is the advancement that has happened in mathematics and in technologies, in analytical technologies enabled by computing. And artificial intelligence has been around since the 50s, but the real revolution is what we call machine learning. It's computers that can, unaided by humans, themselves learn patterns and make decisions. And why is this different? Let me give you a very simple example. Let's say we have to solve a problem, a very basic statistic problem, credit scoring. Should I give a loan to this person, yes or no? And let's say we have 2 variables, the income of the person and let's say the age of the person, right? V1 is income, V2 is age, red is bad customer, green is good customer. How do we predict this? This is how a traditional statistic machine would do this. It would kind of create some kind of curve and would say people above are bad, people below are good. You can see it's making errors. There is still some green above the curve to whom we're not going to give a loan, and there are some red and yellows below the curve to whom we're going to give a loan, and guess what? We shouldn't have given them a loan. This is what machine learning does. Machine learning is not constrained by statistics that are created by humans and will detect the pattern in the data and be able to come with a far more predictive power than any human can be. Now, what's the benefit of that? The benefit of that is that we can do a lot more than we could ever do in the past. In the first artificial intelligence of the 50s, the only thing we could do is what we called rule-based processing. If this customer has had stable income over the last 3 years, give him a loan. Today, we can be much more sophisticated than that. We can leverage all sorts of data, not just for process automation, but for things such as natural languages processing or image recognition. And in fact, there has been an amazing evolution of artificial intelligence and what type of problems that can solve. In 1995, you may have heard of Deep Blue. Deep Blue was the first computer that beat, at that point in time, world champion in chess, Garry Kasparov in chess. It was a machine that could only do one thing, playing chess. But it was beating the most sophisticated player in the world. That was 1996. In 2005, a new machine was created by the same company, IBM, which is called Watson. And Watson could basically do more than chess. It could answer any question. In fact, it won from humans in Jeopardy. So Watson, you can ask a question like, here's data on cancer patients of the last 50 years. Help me to understand what predicts bone cancer. And Watson will give you an answer. It will even give you more answers. That Watson is kind of 10 years old technology, and now it's been evolving and evolving. And so we have new technologies that are called deep learning, and technologies that are at the frontier of artificial intelligence, where computers don't need to be aided; they can learn themselves. That's actually the scary part: is that they don't need to be structured. You don't need to tell them what problems they need to solve. They will figure out themselves. Now, what does this mean for business? Because I'm a business consultant, I help companies. Now, it means you can do a lot. This is just an overview of the type of use cases that are being solved today by companies with artificial intelligence and big data. Things such as pattern recognitions. Companies like Amazon and Netflix, they recommend you a book. They recommend you a video. How do they do that? They see what kind of books you have browsed in the past. They see what kind of videos you've browsed in the past. And they're able to personalize the recommendations to you. You can do understanding of language. There's chatbots today. You can, let's say you have a question on customer service for, let's say, your airline. Instead of calling a call center today, most airlines start to develop chatbots, and you can actually chat with them. You're not chatting with a human, you're chatting with a bot. There's, companies like Danone and other consumer companies are leveraging analytics in their supply chain, optimizing their fleet, optimizing their logistics, and so on. And, it goes to very sophisticated use cases. Let me take the last one, social and emotional sensing. One of the techniques that, for example, banks are trying out is to detect whether people are lying. In fact, today, it's possible in a 3-minute phone call to analyze the tone of voice of a person and predict with a high level of accuracy whether that person is lying. Now, imagine that next time you call your bank. Now, where's the money in this? And where's the business opportunity? This is Eric Schmidt. He is the chairman of Google, and he says that he bets the future of business is digital, big data, and artificial intelligence. Now, okay, great, but do we see the evidence of that? Let me give you one point of evidence. It's what I call the unicorns. The unicorns, if you don't know what they are, unicorns are private companies with a valuation of $1 billion or more. There has been an explosion of such companies in the last 5 years. 5 years ago, there were 20 unicorns worldwide. Today, there are 267. In fact, we've invented a new term called decacorns. 10 corns, and that means private company with a valuation of more than $10 billion. There are more than 20 companies today. The total valuation of all unicorns is 10 times larger than it was 5 years ago. So if you had invested $100 in unicorns 5 years ago, you would have $1,000 today. Now, Why am I bringing up the unicorns? The logos that I'm going to show are the logos of the 4 biggest unicorns in terms of market cap. Uber, Ant Financials, Didi Chuxing, and Airbnb. What do all of these companies have in common? Their core business model is about data. Think about Uber. Does Uber have cars? No. Does Uber employ its drivers? No. What does it have? It has data where drivers are, and it has data where riders are. And it matches those two. It's a data company. Uber is nothing else than a very advanced data company. In fact, pricing on Uber is determined by machine. There's no human involved in pricing your ride. The pricing is completely done by artificial intelligence. And so, if these unicorns are making money, creating value out of data, what does that mean for other companies? Well, there's a lot that they can do as well. In fact, what we've seen from the unicorns is that there are 6 ways that data and analytics create disruptive business models. One of them is to basically enable decisions. For example, insurance companies, should I give an insurance premium to this person or not, and how much should I price it? Real-time matching like Uber, or even in transport or logistics. I have a, let's say in cargo, you've got empty trucks looking for cargo and cargo looking for trucks. How do you match them? Through analytics. Personalization. I've given the examples of Amazon. I've given the examples of Netflix. But what about next time you go to a supermarket and you get a personalized shopping list? Data-driven discovery. Drug companies, pharma companies are using advanced analytics to make a better and faster R&D process, to be faster and more efficient in detecting the next drug. In healthcare, data analytics is being used by doctors to improve the effectiveness of their diagnostic. Does this person have cancer? Yes or no? Is this person going to have a heart attack? Yes or no? Unfortunately, a machine is already better than a doctor. Or fortunately or unfortunately, fortunately for us, unfortunately perhaps for the doctors. Now, to kind of make it come real, I'm going to show you one small video. It's a video of a Japanese retailer that used advanced analytics to solve a core problem that any retailer has, which is, where shall I open my next stores? There's a lot of money involved in making the right decision or wrong decision. In fact, the location of a store, if you're a retailer, is the single most important decision that you make. Let's look at this video.
Data, but struggled to find which of hundreds of characteristics mattered. So a team of Mckinsey retail experts collaborated with a powerful artificial intelligence-powered research platform to create a model that could do just that. Data used in the model included every retail store in Greater Tokyo, over 150,000 locations, detailed postcode level demographics data and real estate prices, and over 1 million points of interest pulled from open source data online. From billions of potential combinations of factors, the model came up with the top drivers associated with high and low performing stores. Some of the details were surprising. For example, it found that stores near laundromats had higher profitability, and that stores nearby service stations also had better performance. But it also did something else. By automatically iterating through thousands of potential locations and calculating likely profitability for each one, it was able to identify more than 1,000 locations that could expect a high operating profit. McKinsey Analytics in action. From zero to deep insights and better decisions in just over a month.
In this example, things were detected that human planners could never detect. Like, for example, why would you open a retail store close to a laundromat? Actually, in hindsight, you can make sense out of it. The machine came up with that. There's many young people in Tokyo that don't have enough money to have an apartment big enough with a washing machine, so they have to go to a laundromat, and then they have to wait for an hour. If you open a store close to that, well, you get that traffic. So that's how machine learning can be applied to companies and generate a lot of value by basically improving the quality of their decisions. The value is real. The statistics that you see on this chart is the average impact we've achieved in various industries. You can see revenue impact and cost impact. Cost impact, for example, even in manufacturing, you can do preventive maintenance. Predict when do I need to maintain and do something about this machine. What spare parts do I need? On the revenue side, how should I price my products? What promotions should I do? This is where analytics and artificial intelligence can make a huge difference. Now, one thing is, what can a single company do with data? Another thing is, what can two companies do together in leveraging data? What we have found is that 1 + 1 is 3. Imagine you're a bank and you've got a telco. A telco has data on do people pay their bills and do they pay their bills on time in a regular basis. That type of information is extremely relevant for a bank because a bank can then determine, can we actually give a credit to this person? But there's more sophisticated use cases imaginable. Let's take motorbike insurance. It's very difficult for an insurance company to price that. Is this going to be a high-risk driver or a low-risk driver? Again, if you had the data from a telco, you were to know, when is this guy driving his motorbike? Is it at 2 a.m. at night, or is he driving it in the quiet hours of the day? Is he driving it fast? Is he driving it slow? How much is he driving it on a day? With that information, you can actually tailor and figure out, should I give an insurance premium to this driver or not? And how much should I price it? This is what we call data collaboration. When more than two companies work together, we call it a data ecosystem. We have looked at kind of different industries, and we've found 12 of those ecosystems where companies can work together. Let me just take an example of one of them, housing. In housing, if real estate brokers, real estate developers, insurance companies, furniture sellers were to combine their data, they would be able to understand, who are the people that are looking for new homes and what are they looking for across the home, across the insurance, across the mortgage, across the furniture. If those companies were to share that data, they would be able to get insights that none of the companies individually could have today. And that's what you can do in each of these ecosystems. Ecosystems are real. Two examples here. One is Ping An, which is a banking and insurance company in China, which has built 5 ecosystems today in health, in medicine, in auto and housing, in gaming, and in food. In health, they today have more data on the health of Chinese citizens than any other organization in China. And it helps them to advise people on doctors and hospitals, but even more than that, it gives them amazing information on medical insurance, and it helps them in their core business. The second example is Data Republic. In the case of Ping An, it's one single conglomerate building an ecosystem. In the case of Data Republic, Westpac and National Australian Bank, who are two leading banks in Australia, and Qantas, who is the leading airline, they decided to basically bring together their data in a common data trust, and they established Data Republic. It's a secure data trust where data can be shared without revealing the private data of each customer. To that, they enable, again, this kind of ecosystem value, and by now there's more than 40 companies that have been part of that platform. Now, if I have convinced you that there's value in data, then the next question is what to do about it, how to go about it as an organization. There's 4 critical steps that we have found that a company needs to do to unlock the full value from data. Number 1 is to focus on the business value. Number 2 is to have a modern data architecture. Number 3 is to have new capabilities. Number 4 is to have an agile way of working. Let me go through each of them. Whenever we go into a business, we found that there's an abundance of ideas to apply analytics. There's actually more ideas than a company can deal with. So then the question is, where do you start? Our advice is focus on business value. Understand which use cases bring the biggest value for the company. This is an example from banking with the use cases that are applicable to banking. And you see they're not all the same. So you've got to start with the ones that have most value and are easiest to implement. Number 2 is what we call a modern data architecture. When we go into companies, what we often found is what I call a spaghetti architecture, which means data is fragmented in 500 systems, fragmented over the company, and it's a mess. In one oil and gas company that we went in, we found that they had data so fragmented that we couldn't even start. There was even data on individual laptop hard drives that wasn't even kind of on a network. So one key thing to start is to create a common data lake where all the data of the company is put together and easily accessible. In that data lake, create a data model with a data dictionary that allows to interpret each of the data and where you can kind of actually, over time, evolve your algorithms even if the underlying systems change. 3 is new capabilities. I think most companies understand this, that you need you probably need data scientists. Yeah, you probably need data scientists to do something with analytics. Well, we would say, yes, you need data scientists, but it's not the only thing you need. To build the modern data architecture that I just talked about, you need data architects and data engineers. Data engineers to get the data out of the systems and interpret it. In fact, we have found that for every to keep a data scientist productive, you need at least 5 data engineers to feed him with data. Second is what we call business translators. Business translators are people that have an understanding of the business, an understanding of the domain, and can then frame the problem that the data scientists need to solve. And without those business translators, the data scientists are a bit lost. In fact, we've so often seen companies that basically hired 10, 20 data scientists, puts them in some kind of room, and then they're having fun, they're having great academics, but they're not adding value to the business. We have found that the business translators that translate business problems into something that a data scientist can tackle is key to unlock value. And the rule of thumb is for every data scientist, you need 10 business translators. Third is what we call agile. You need a new way of working. These people that I just mentioned need to work together, and they need to work together in a different way. They need to work as an autonomous team, empowered to solve a problem, and they need to be in what we call rapid prototyping mode, which is don't try to solve a problem to perfection. Take a business problem, rapidly prototype a solution, iterate, learn from user feedback, learn from business impact. If it works, scale it up in production. If it doesn't work, try to improve it or take the next use case. Lastly, some ideas for Thailand. And I would say I've worked a lot in Thailand. This is a country where I believe data monetization has a lot of potential. You probably have one of the most sophisticated consumer markets in Asia. And when I mean sophisticated, I mean the consumer is sophisticated, so what you offer to one consumer needs to be different than what you offer to another consumer. Any consumer company addressing Thai consumers without analytics, is lost. And so I think those consumer companies need to leverage analytics, but also manufacturing. This conference is about Industry 4.0. Industry 4.0 heavily relies on analytics to take if you want to take the value from IoT, from robotics, you need to have the analytics to make sense out of the data that those IoT devices and sensors are generating. Now, what does Thailand need to do? A couple of things that we have seen other countries do that could be ideas for Thailand. Number one is you need talent. You need to grow the type of advanced analytics talent to basically make this possible. We have seen other countries develop specific curriculums for data scientists and kind of incentivize people to choose those educations. We've seen also other countries create incentives to attract leading data-focused startups to be based in their country. So can we do that for Thailand? Can we create incentives for data scientists to come and work here? Number two is, one thing is, as I said, is the data scientists. The other thing is what do companies need to do? And companies will need to train a lot of their existing people to take advantage of analytics. I've talked about these business translators. We think that probably across Thailand, we need to train 10,000s of business people to understand how they leverage analytics in their business and create these business translators for Thailand. Thai companies, many of them are focused on one industry. How can we create data partnerships where they start sharing data, where a bank and a telco start sharing data? I think there's a role for government potentially to create the incentives and the right environment to make that happen. Third is data infrastructure. Big data requires a lot of storage and a lot of computing. It requires something that is known as the cloud. Now, unfortunately, today, none of the big cloud players is present in Thailand. Alibaba decided to invest in Indonesia. Why not in Thailand? I think it begs a question and an answer. And I think such infrastructure is key, not just at an individual company level, but at the country level. And there are some incentives that can be created. Number 4 is regulation. There is a need for regulation to make data analytics happening. Of course, consumers will be concerned, should be concerned about the protection of their privacy. The European Union and the US have made real progress in that and have put in place practical frameworks for privacy and personal data protection. I think we need to work on something like that. And then there's also need for regulation around security, particularly cybersecurity, because the more that we will leverage this data, the more that we will be open and vulnerable for attacks. There's also, last but not least, I think a role for the government to play to create what we call an open data environment. If you want to attract startups or you want to get students to play with data, they need to have data. The Singapore government several years ago started with an initiative that they call the Open Data Initiative. They have a portal that is freely accessible by anyone. Anyone in Singapore, a student, a startup, to use government data in health, in education, and environment. And those data sets are fantastic, to train students or for startups to kind of test out their analytics capabilities. In summary, what I hope you take away from my presentation, number 1 is, this is not a hype, it's real. Artificial intelligence is real and it's finally there and it's changing rapidly. In 10 years from now, the computer you have bought will have more computing power than your brain. And companies are applying that technology in many, many different contexts. Number 2, data analytics creates real value for business. There's real money in this technology. And there's even more money if companies work together in partnerships. And even more money if companies work together across multiple companies to share data in so-called data ecosystems. We have identified 12 of those, and we think that all those 12 are applicable to Thailand. Thirdly, to unlock the value, organizations and the government need to do stuff. On an organizational front, they need to understand and have an agenda to get the business value from big data out. They need to implement modern data architectures. They need to build new capabilities in their organization, and they need to implement an agile way of working to foster the full value extraction. And lastly, I shared some ideas for how Thailand can unlock data monetization as a country and as a society. Thank you for the attention. I hope you enjoyed my speech, which I know is the last one of today. I'm available for any questions. You can reach me on Twitter, email, or LinkedIn. I encourage you also to visit our website where we have more information. Thank you so much. ขอบคุณครับ
ขอเสียงปรบมือให้กับสปีกเกอร์ของเราด้วยนะครับแล้วก็ณลำดับนี้ผมขอเรียนเชิญคุณกสิทธิธรภูพราดัยให้เกียรติขึ้นมอบของที่ระลึกให้กับสปีกเกอร์ของเราในวันนี้ด้วยครับขอเสียงปรบมือให้กับสปีกเกอร์เราด้วยครับ